Hey, hi everyone. Today we are going to solve this important problem and it is very interesting also. So basically they are saying ki we are having a n steps, okay, n staircases, and to reach the top we have a two ways. Either we can jump by one step or two steps at any point of time. So we have to figure out how many distinct ways are there to climb to the top step. So in this case, suppose the steps are two. So, what is given to us at a time, we can jump by only one step or two steps. In this case, to get on the step two, we have two options: either take one step or take a two steps from the zero step. In the case of a three, there are three options: take one step, and take one step and two step, and alternate two steps and one step. So these are the examples. Let's try to understand the brute force solution for this. So let's start understanding how can we solve this problem. So we will start with the base cases. So suppose the number of steps equal to 1. So this is a zeroth step and this is one step. So in this case, there is only one way to get on the top step. Okay, which is a jump by one step. So in this case, answer will be 1. Take another base case which is 2. In this case, this is 0, this is 1, and this is 2. In this case, what we can do, we can jump by one step to the 1, then we can jump by one step to the 2. So this is a one way, and another is we can jump by two steps to the 2. So there are basically two ways. So consider these as a two base cases, and later on we can build on the top of this. Okay, so let's consider number of steps equal to 3. In this case, this is a zeroth step, this is first step, second step, third step. To get on the first step, we can jump by one step. Again, here to second step, there is a one step, and we can jump by two steps from 0 to 2. In this case, to get on the first step, there are let's say the ways, distinct ways to get on the step. For one, there is a one way. For two, there is a two way. So in this case, to get on the third step, what we can do, we can jump from this to this, that is one, this to three, that is two, and two steps from the one. So in this case, that will be the addition of these two. So to get on any step, what we have to do, we have to do the addition of a number of distinct ways from the previous and previous to previous steps. Like for get a number of distinct ways to reach the third step, we need to add a number of distinct ways to get on the first step and second step. So that is a brute force solution, and at every step we have two choices. Like we have to calculate a two number of ways on the two distinct steps. Okay, so in this case the time complexity will be O of 2 to the power n, and space complexity will be also same due to the recursion 2 to the power n. So let's try to code this. Yeah, we can start coding the problem itself. So first of all, write the base cases. If number of steps equal to 1 or number of steps equal to 2, return the base, which is n. And in other case, just take like number of total steps. We can name the variable as a total steps equal to 0. Take the ways to reach n minus one step equal to self dot call the same function climb stairs for n minus 1, and copy the same variable name for the two steps n minus 2 steps self dot climb stairs which equal to n minus 2. Okay, let's add the steps. Total steps equal to, just copy those variables and do the addition here. That's all. Remove this variable here, no need of initialization, and return the total steps. This is a basic brute force recursive solution where we are doing addition of a number of ways at n minus 1 and n minus 2 steps. Let's try to run this. Yeah, it is working fine. If I try to submit this code, right, it will fail because it is not completely optimized. The time complexity will be 2 to the power n, which is not acceptable. So in this case, I won't submit this problem. And let's try to submit the problem. Let's try to figure out the time complexity error. So we should get the TLA exception. Tick, 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 tick. Yeah, you can see it is taking a too much time, and this is exception. It is getting a time limit exceeded. So in this case, we have to optimize this problem using the dynamic programming. What we can do, whatever is our calculated results, right? We can reuse them in the dynamic programming. So let's try to understand how can we solve this problem or optimize this problem using dynamic programming. So let's get to the pen and paper.
Let's draw the recursive tree for the solution we have coded. So suppose the number of steps is a 6. Okay, in this case we will start with a 6 and we will add the uh, number of ways at a 5 and 4. Okay, for 5 it will be 4 and 3, for 4 it will be 3 and 2, and for 3 it will be 2 and 1. In this case we have reached the base cases 2 and 1. So here we will return the values, we will add those values at 3. So we have calculated the number of ways to reach the 3 steps here. Okay, in this case we will return this is a base case, number of steps to reach the 2 is 2, so we'll return that. So we will add that value, these are the number of ways to reach the 4 steps, here we will return that. And in this case you can see there is again 3, so this is 3 2 1. In this case you can see we have already computed the number of steps to reach the 3 steps, and in this case we are recalculating it again. So the dynamic programming says whenever we are calculating something, right, using sub problems, and if we are facing that same problem again without calculating that, we can reuse the existing calculation, existing result. Okay, in this case we will calculate this, we will return, and at 5 number of steps to reach 5 we will return this, and again for 4, so 3 2 and 2 comma 1. So we can still avoid this, right, because we have already computed this stuff. So what we can do, we can, without storing this, we have to calculate it again and we have to write, and at 6 we will get a number of steps to reach a 6 steps. So let's try to understand how we can store this. So suppose this is n equal to 6, and suppose this is a 6, this is 5, this is 4, this is 3, this is this is 4, this is 3, this is 3, this is 2, this is 2, this is 1. In this case number of steps to reach the 2 and 1 are the base cases. Here we will return 2, here we will return 1. Okay, and number of steps to reach the 3 are 3, and in this case we will store that value with the 3 as a key and number of ways as a value into the map or a hash table. Again this is a base case, so we will return 2 here, here we will return 3, 3 plus 2 is 5, so number of ways to reach a 4 is 5, so we'll store another entry again. So when we are calculating for 3, right, we have already calculated the number of steps to reach the 3, so we will just reuse the result rather than calculating it again. So we will just return 3, and the sum will be 5 plus 3 is 8. Okay, and we will again store one entry for 5 into 8, because number of ways to reach a 5 steps is 8. On the top of that, when we are calculating for 4 again, right, we can see there is already entry into the hash table, so we can just return that same result. which is 5, and 8 plus 5 is 13. So the number of distinct ways to reach a 6 steps is 13. So let's try to code this.
So suppose first of all, into the constructor, create the hash table to store the calculated results. Self.st.this, and in this case, add a base case. If n is equal to 1 or n is equal to 2, then return the n, and just add one step if we have already calculated the result. If n is into the self.st, it is present into the map, just return the value from there itself. So don't recalculate it again. And on the top of that, if it is not there, then calculate ways to reach n minus one steps will be self dot climb stairs equal to n minus 1, and copy the same line for n minus 2 steps. N minus 2 steps, just a single change, and add the total steps. Total steps to reach a n step is a number of ways to reach a n minus 1 step plus number of ways to reach a n minus 2 steps. So let's expand this console and store this result into the map once we have calculated, equal to total steps, and return the total steps. So in this case, the time complexity will be, as we are visiting each element only once, right? That will be a linear, and space complexity will be also linear because we are storing like a single entry for each element at once into the hash map. So let's try to run this. Yeah, it is working fine. Let's submit this. Yeah, it is submitted. Let me write the time and space complexity. Time complexity will be O of n, which is linear, and space complexity also be O of n. So this is a top to down solution using the dynamic programming. So let's try to understand how we can solve this using the iterative solution from bottom to up.
So as we have seen, top to down approach for solving this climbing stairs problem. So into the top to down approach, we have given the target element and we will come to the base cases. And from here, we will build one by one, one by one, one by one, and we will get the answer. So that is a top to down approach into the dynamic programming. So let's understand what is a bottom up approach. So this is a bottom up approach. In this case, we will just do the reverse thing what we did into the top to down approach. Here we will be having a base cases. For climbing one stair there will be one way. For climbing two stairs there will be a two ways. So from these we will build until the given element. Suppose this is 6 7 8 jo bhi hai. So in this case we will start from the base cases and incrementally we will build until our target element. So let's try to understand. So what is a f of 1? Like a number of step. It is 1, right? That is a base case. What is f of 2? It is a number of steps. It is a base case, so which is 2. What is a f of 3? So it is f of 2, which is n minus 1 plus f of 1. Okay. What is f of 4? In this case, it is a f of 3 plus f of 2. So can you see the recurrence relation? So for each element, we need to know the number of ways at the previous two steps. So what we can do, we can start with the 1 and 2 and we can incrementally build for f of 3, f of 4 until the f of n. So whatever n is given to us. So let's try to code this, and the time complexity for this approach will be O of n, because for each element we will be visiting once. Okay, and space complexity will be O of n, because for each element we will be storing the number of ways into the array. So suppose for one there will be one way, for two there will be two ways. While calculating f of 3 we will add number of ways for two steps, number of ways for one step, and whatever is the result, we will store that into the array where we have marked as a 3. And same after calculating for 4, we will store that. And while calculating for f5, we will just take these two results and we will add here. So that is a bottom up approach. We will start building from the base cases to the given element. Yeah, that is one of the iterative solution which we are going to code. Okay, let's.
In this case, the code part is very simple. First of all, add the base cases. If n equal to 1 or n equal to 2, return n. And if that is the not case, let's create the DP array where we will store the number of ways for number of stairs, where stairs will index will act as a stairs, and the value on that index will act as a number of ways to reach that stairs. So first of all, do the 0 for x in a range of, so we need at until n plus 1, and just fill the base cases. So for 1 there will be a one way, for 2 there will be a two ways. Now iterate from the third step to the nth step. So for index in a range of 3 comma n plus 1, and at each step, so which is an index, just add the number of step at the previous index plus previous to previous index, which is a index minus 2, and at last just return the number of steps at the nth index, which is a number of ways to reach a n steps. So it is working fine. Let's try to submit this. Yeah, it worked fine. So let me write down the time and space complexity. So it will be O of n. As you can see, we are visiting each element once, and space complexity will be also O of n, because for each number of step we are storing the number of ways into the array. So that is a iterative solution using the bottom up approach. We can solve this without extra space also. So let's try to understand on the pen and paper.
In the previous approach, what we have studied, we will be just iterating over the array, and to get a number of ways to reach a n steps, we will be just adding the number of ways for the previous two steps. So let's start with example 0, 1, 2, 3, 4, 5, 6. In this case, you can see this is a number of ways to reach a 1 is 1, number of ways to reach a 2 is 2, number of ways to reach a 3 is the addition of these two. In this case, that will be 3. For 4, the number of ways to reach the 4 is this 2 plus 3. In this case, this will be 5. Okay. For 5, the number of steps will be number of steps to reach a 3 and 4. So this is pretty straightforward. 8. And for same for the 6 also, we just need to add the number of ways for the previous two steps. Okay. In this case, that will be 13. So can we skip creating that particular array? You can see, suppose this is x, this is y, and this is z. In this case, into the next step, what will happen? Z will reach to the 4, y will come here, and x will be here. In the next step, z will come to the 5, y will come to the 4, x will come to the 3. In this case, can you observe one pattern? Z is equal to x plus y, and y is equal to z, and x is equal to y. So this can help us to avoid the whole array, which will reduce our space complexity from the linear to the constant one. This will reduce our time complexity. This won't reduce our time complexity, but definitely it will reduce our space complexity to O of 1. So that is a optimized approach for the bottom up. So let's try to code this.
So first of all, let's note down the relations. As we have seen, z is equal to x plus y, y is equal to z, and x is equal to 5. In this case, first of all add a base case. If n is equal to 1 or 2, just return that. If n is equal to 1 or n is equal to 2, return n. Then steps or ways to reach n minus uh, minus 1 steps is equal to 2, which is initially this is a pi. Initially it is a n equal to 2. Ways to reach n minus 2 steps, which is equal to 1, which is ideally x, and initially is equal to 1. Total steps, assign it to the 0, and now iterate from third step to the n step for index in a range of 3 comma n plus 1. Take a total step is addition of n minus 1 plus n minus 2. Okay, so that is the first step, and the second step is y is equal to, which is this one. Okay, so first of all we need to assign x. Assign x is equal to z. We need to move this condition before y is equal to z to keep the value of y, and y is equal to total steps, and return the total steps. So that is the pretty much. Let's try to run this. It is working fine. Let's try to submit this. Yeah, it is working fine. So the time complexity will be O of n, and space complexity will be O of 1. So this is reduced. And this is a pretty much important problem also. This question was asked to me into the Microsoft first DSA round, I think, and we can solve this problem from brute force to the optimized approach into the 4 ways. So please go through this video once again if it is necessary. ठीक है, चलो bye.